Today we are going to solve another exercise under circuit exam ITC and HEC page 2. You have the exercise with you. So the first exercise was to find the current flowing through the resistor R2. Here we discovered that the current flowing through the resistor R2 will be the voltage at the higher potential minus the voltage at the lower potential divided by the resistor across. So we can simply write this relation. This means that let's call that current I2 will be equal to V at the higher potential here is VB minus V at the lower potential VA all over the resistor across, which is R2. We have all the elements, but we don't have this VA. We don't have the unknown point here is only VA. So we are going to find VA and get up and perform that operation. Let's call this equation number 1 and get so in junction A we can apply Millman and get that voltage. At junction A we have VA, which is equal to 15 on that resistor 5 plus 10 on 10 plus 0 on 4 plus 6 on 1 on 5 plus 1 on 10 plus 1 on 4 plus 6. Okay, let us arrange this operation very well. When you perform this operation, we are going to obtain VA equal to 10 volt. Let us square it. Okay, let us now take this equation, that VA equal to 10 volt, and come and substitute in equation 1 that we performed before. In equation 1, let's call that equation, let's say equation 2. So if we take equation 2 in equation 1, 2 in 1 is going to give I2 equal to VA. VB was 10 volt minus VA 10 volt divided by R2, which is equal to 4 ohms, and this operation is going to give 0 amps. Once you obtain a current of 0 amp, means that the battery 10 volt battery is not charging, is fully charged, means that non-current is flowing through the resistor R2. The battery 10 volt battery is fully charged by the 15 volt battery. Okay, if you have a question, don't forget to ask in the description section below. I will be happy to answer that question for you. Means that I2 is equal to 0 amp, fully charged. No problem. Let us now move to equation exercise number 2. Find the voltage V across the 4 ohm resistor. Here the process for me is to transform this Thévenin source into Norton source, so that I will be able to add the 2 Norton sources and make current divider and get the current flowing through the 4 ohm resistor. At the end, apply Ohm's law and get the voltage across 4 ohms resistor. So we are going down to redraw that circuit to perform it very well. I was saying that the aim here is to first of all transform the Thévenin source into Norton source. We are going to take, we have here positive, it's a Norton source current in parallel with the resistor, and we have there that 4 ohms resistor that we want to find, and you have this current source at the output, which is equal to 3 amps. Here the current, this current will be equal to 6 divided by 8, 6 on 8 amps, and this resistor will remain 8 ohms, and here is 4 ohms, and is the voltage that we are looking for. So we can find the equivalent current source, Norton current source. We are going to add the 2 current source all in parallel with the 2 resistor. So we can write like this. we have the two resistor and this other one here as well, and here is 4 ohms, here is 8 ohms, and this current will be 6.6 on 8, 6 on 8 plus 3 is going to give, let's say here 8, and there time 8, 23 times 8 plus 6 divided by 8 is going to give me 3.75 amps. 3.75 amps. Okay, we discover that when we reach at this junction, let's say we have a junction A here, knowing that this is the reference of the voltages, we discover that 3.75 amps which is coming there is called I. We reach this junction and divide it into two branches, one and this other one, I2. So we can apply current divider and get the current flowing through 4 ohms resistor. At the end, applies Ohm law and get the total voltage. Let's say the current I2 by applying Ohm's law, by applying current divider, will be equal to 8 ohms times the main current, which is here 3.75, divided by 8 plus 4. Let us apply this expression together. Okay, this operation is going to give 2.5 amps. Means that I2, the current I2 is equal to 2.5. Now, by applying the Ohm's law, we can simply perform saying that V, which is the voltage across R 4 ohms, will be equal to V that we are looking for, will be equal to I time I2 here time R 4 ohms. Okay, so it is going to give me 2.5 amps time that 4 ohms resistor, 4 ohms, and when you perform this, it's going to give 10 volt. That is that answer. If you have a question or any suggestion, don't forget to ask in the description section below. I will be happy to answer all your questions. And don't forget to share to your classmates so that we can perform and realize this video very well. And don't forget to subscribe as well. Okay, let us move now to exercise number 6. Find the voltage V across the 8 ohms resistor. Here we discover that we have one Norton source, one Thévenin source. The purpose here is to, first of all, to transform maybe this Norton source into Thévenin source and get V, the voltage V, by applying Millman. Otherwise, you can still transform this Thévenin source into Norton source at the end, find the current flowing through 8 ohms. As for me, I'm going to transform this Thévenin source into Norton source into Thévenin source, so that I will be happy. It will be easier for me to apply Millman at this junction. Let's say V. Let's call that junction. Let's call that junction. Let's say M. We will say that I like too much M, but it's like that, knowing that the reference of the voltages will be equal to 0. Okay, so I'm going to transform that Norton source, that Thévenin Norton source into Thévenin source. So I'm going to transform it into, I will have a resistor and the voltage source. See, the direction of the current means that the positive terminal will be looking down, plus minus this other resistor, and I have this other one here and this other branch for this Thévenin source, and the direction is like that. And here we are looking for this voltage plus minus, we are looking for this voltage, and here is 8 ohms, and here 2 ohms, here 3 ohms, and here 12 volt, and this voltage source will be equal to 4 ohms times 3 amps is going to give 12 volt, and here the resistor will be 4 ohms. For this one, we can perform the equivalent resistance of this other branch and have something which is very simple to apply the Millman theorem at that junction that we set A. So I'm going to redraw the circuit so that it will be very simple for me to apply. I have here negative and minus down. I have the load in the middle, and here I have this source, and I have this junction A. Here is 3 ohms, here is 12 volt as well, 12 volt, and there is 4 plus 2 is going to give me 6 ohms, and this voltage source is 12 volt, and this load in the middle is 8 ohms, and we are looking for this the voltage across this positive and this one, which is equal to VA. So we have transformed the diagram very well. Means that it will be very simple and very funny for us to perform Millman at junction A. Means that VA at junction A by applying Millman is equal to, see very well the direction of this voltage. Means that the voltage at this point is negative 12. Means that we have negative 12 on 6 plus 12 on 3 plus 0 on 8 all over 1 on 6 plus 1 on 3 plus 1 on 8. That is it. Is correct now. Once we perform this calculation very well, let me go down and get a small area, will be equal to negative 6 divided by 6. This one will going to give me negative 2, and 12 divided by 3 give me 4 all over 1 on 6, which is equal to 4 plus 8 plus 3, 4 plus 8 plus 3 all over 24. Now when you have operation like this one, you take the first fraction and multiply by the reverse of the second fraction. So we are going to have VA, don't forget that is TVA. VA will be equal to 2 divided by 15 times 2 divided by 15 on 24. You take the first fraction and multiply by the reverse of the second one. So when you perform that operation, we are going to have VA, which is equal to 2 on 1 multiplied by the reverse 24 on 15. 24 on 15. And when you perform this operation, we are going to obtain VA equal to 3.2 volt. VA equal to 3.2 volt. So as we got VA equal to 3.2 volt, means that that voltage that we are looking for is here. VA will be equal to 3.2 volt, which is the same as the voltage across 8 ohms resistor. Is that the small voltage that we are looking for is equal to 3.2 volt. Any question? I don't think. Is that here V is equal to 3.2 volt. Let us record in the in the first page so that we will have the cover of this video very well. Means that v is equal to 3.2 volt, and the other volt that we find before, we got 10 volt. It's normal to record all the value in the main page, and v here is equal to 10 volt. Means that we have succeed this operation. Okay, we have solved this one. Okay, correct. This other one, okay, and this last one, okay. So if you have a question, don't forget to ask in the description section below, and if you are new in this channel, don't forget to subscribe so that you not miss a video.